Hello everyone, welcome back to my tutorial. In this tutorial, we are going to solve this connecting lug. This abacus case. We will solve it here and we will check the results. So this is our geometry. First we will model this geometry. We will assign this material property and we will apply the pressure will be a uniform pressure will be 50 megapascal. We'll apply this pressure here. Okay, now just open the salome. This is simple as static analysis. Just the geometry is a little complex. We'll model this geometry and we'll solve in salome. Just go to geometry. First go to new entity, basic. There is an option called 2D sketch. First just apply it, then you just go to relative. I just want to draw this line. This line length is 0.125. Relative x is 0.125. Just off this, just apply. Then I just want to make a circle, relative radius. Now the radius is 0.025. Here they have given 0.025. Total height they have given is 0.05. 0.05. Why? We need not to specify anything. 0.025. Yes, so this is our radius circle. Just apply it. Now just make it line again, relative. Now just go here, this length 0.125 in negative direction, so minus 0.125. just apply. Now we can give sketch closer. It will close the sketch as a linear line, straight line. Now we have got the sketch. Then what we want to do, we will build the face, or we will create one more circle here. First we will make a point. Go to new entity, basic point. You need to specify the coordinate. X is 0.125, y is 0.025. The center we got. Just apply. Now we'll go to new entity, basic. There is an option called circle. Choose the point as vertex, OZ. Radius we need to specify. Here they are given radius as 0.015. 0.015. just apply and close. So this is the connecting lug. Now we have created the geometry. Now we can switch on this axis. Now just select both the sketches. Go to new entity, build face. What it will do, it will build the face in between the sketches. This is our geometry. Now we can save this file. Study 2. This is having a thickness of 0.02. So select this face, go to new entity, extrusion. For extrusion command I have created a separate video. You want to learn extrusion, you can go there. Go to vector. Vector is OZ. Now thickness is 0.02. Just simply rotate the object and have a look. This is our geometry. Just apply and close. Now we have created our geometry. Then we'll create groups to apply the boundary conditions. First is we need to fix it here, the left side. The next is we need to apply a pressure of 50 megapascal in this bottom surface, not the top surface. For that, just have a look here. We don't have a single surface, bottom surface separately. We need to divide this geometry into, here there is separate surface. For that we need to create a plane. So go to new entity, basic, there is an option called plane. Select this any one of the point, vector, normal to Z, sorry, Y, yes, give a size of 2, 1.5, yes, this is enough. Just apply and close. Now we need to cut the geometry using this plane. It's nothing but splitting the surface. Instead of surface, we are splitting full geometry. Go to operation, partition. Extrusion is the main object. Tool object is the plane. Just apply and close. Now see, we got surface at the bottom surface. Bottom and top also, we require only the bottom. Now we'll create groups to apply the boundary condition. Right click here, create group, face group. Left side we need to fix it. Select both the surface, add, fix, just apply. Here we need to apply pressure. Now both the groups we have created. Now we will save this file. Now we'll move into mesh module to create the mesh. Select the partition one, mesh, create mesh. Here we are going to create a TET mesh. Choose the NetGen 1D, 2D, 3D algorithm, and here you choose simple parameter. Here we can go for one more algorithm called NetGen 1D, 2D, 3D algorithm, NetGen 3D parameter. Here we can very fine, we can choose, just OK, apply and close. Right click, compute. Instead of specifying the element size, it will automatically create the coarse and fine mesh. So here we need a fine mesh, here we need a coarse mesh. Based on that it will generate. Actually we'll get more stress in this location. Edit mesh, little finer we required. 0 and 0. Just say OK, apply and close. Right click, compute. Now we'll take this mesh for solving. So check the groups before solving. Here we need to fix it. Here we need to apply the pressure. Now just go to aster study. This is a simple case. We can quickly generate the setup by using a wizard. Right click here, go to add a stage with assistant. There is an option called isotropic linear elasticity. Go to next. Mesh is a 3D mesh. Check the material property, same only. Just go to next again. Here we need to fix it all the direction. We need to arrest the displacement in XYZ. Pressure. The pressure value is 50 megapascal. That means 50 into 10 power 6 Newton per meter square. 50 e power 6. Save it. Go to pictures, code aster, connecting lug. We'll check the folder again. Yes, this is the file. So I'm just giving name as result3.rmd, finish it. Now it will calculate only the primary variable displacement. So to get stress everything, go to post processing, call champ, reuse the previous data. Here we need to calculate sigma L sigma node. Here option called SAEQ node. Just apply, save OK. Output to just go there. Small thing, we need to edit it. Instead of meca static, we need to change into call champ. This is make it into tout champ as yes. Switch it on mesh also. Just OK. Just apply, save OK. Now we have done creating setup everything. Now we can run the case. Go to history view, stage 1. Save this file before running. Just run the case. This is a simple linear static analysis. So we can generate the command file or setup using wizard itself. If it is a non-linear or dynamic analysis, we can generate step by, we can use stages, and we can generate the command step by step. Now it is solved without any error. If any error comes, we have to rectify by seeing the error message. Just save this, go to paraview to do the post processing. Two things we have to check. One is displacement, another one is stress. This is steel material, we have to check with the von Mises stress. The final one is result 3, that is the name I am given. Just apply. Now we can check the meshes also. So this is the mesh we have done. Displacement. Now we can see the deformation, how it is getting deforming. Little scale factor we provide. Yes, we are applying pressure here, it is bending like this. Now we can check the stress value of von Mises. So this is the von Mises stress. So I just changing it to blue to red, and this into a 12. So this is the value, it comes around 350 megapascal. It's coming, the maximum stress is 350 megapascal in positive. Here it is tensile, whatever it is, here it has to be compressive. Here it is tensile, it is compressive. We are seeing von Mises stress. To see von Mises stress signed value, just there is a option called von Mises signed value. Here you can see it. Here 350 megapascal positive, that means tensile. Here negative, that means it's a compressive. Here we cannot see it normal von Mises stress. In von Mises signed only we can see it. And this one is a stress cast stress. It's coming little higher, 360. These are principal stresses. Similarly, we can check with the directional stresses also. Sigma Z, we can check it. This will only come higher. Sorry, sigma Y. Sigma XX is 520 is coming maximum. Sigma Y is 220. Sigma Z is also 220. X stress is much higher. So this is the way we can check. We can animate this also. So just we are in the raw vector. Here there is an option called a play button. Just click it here, create animation track, just say OK. Now just animate it. So this is the way it will go. There are 2-3 things. So this is the way we can do the post processing of our model. Thank you for watching my videos. Please subscribe my channel for more videos. Thank you.